Okay, so previously, this is basically a representation of what the old system looked like. I coined the term out of the old for this because we kind of wanted to throw all of that in the rubbish. So let's start in the top left. You can see that's basically a waterfall-based pattern for application development, which is still a very traditional, very well-used system. But when you take on board things like agile methodologies and you want things quickly out the door, the waterfall mechanism doesn't really work too well in the development cycle. So we wanted to get rid of that. They were using ASP.NET, the MVC modeling of the ASP.NET. For those of you not familiar, that's Model View Controller. And that's essentially just a way to build, certainly something that can help you build web applications fairly seamlessly and separate each set of business logic or requirements into its own category, essentially. It's a solid way to build an application, but when you're thinking about web applications, there are better things. What you see in the middle is a monolithic architectural pattern, which is, again, still a very solid principle, still something that works for a lot of organizations, but it wasn't going to work for us. And so, for those of you not familiar with the monolithic application, essentially you've got 3 layers sitting on the back. You've got a database, and those are presentation, business logic, and data access, and that's essentially all within one big gigantic service. So it's one big service. It makes development fairly quick to start with, but as you scale your application, you start to see the holes and things start coming out of the woodwork and making it a little bit difficult to work with. Oh no, actually, sorry, I've just realised. On my left is the waterfall. On my right is the MVC model. So MVC on the right and waterfall on the left. I've kind of gone through those already, so I won't bore you with any more of those details. So this is how it used to look. Very traditional, still working for a lot of organisations, but we at FIXER like to go with a more modern approach. We like to take it one step further. And so this is what the new system really looks like. And I'm hopefully going to describe this as best I can, and if you lose me, please feel free to ask me any questions at the end. I like to think that this is a very modern approach to a lot of to web application development. So on the left-hand side, we've got the .NET Core Web Framework, which is a C#-based web framework. It's the solid new language built by Microsoft. It's open source, so anybody can use it and play with it, and a lot of people are saying this is the future. It still follows an MVC pattern, but we're actually taking away the view from .NET Core and instead just going with the model controller side of things. So what we're trying to achieve with that is having services, which I'll get to in a minute, which provide a series of endpoints that things can communicate with to retrieve data. So it's a request response style system, and it works pretty well. We've then got the actual architectural pattern we decided to go with, which is a microservice based. For those of you not familiar, all that really does is gives organizations the opportunity to spread out the business logic in each individual service and give you the opportunity to both scale your application really well and also detach and decouple services and ensure that there's no reliance on any other service throughout the system. So one service goes down, the rest of the services should, in theory, be able to continue to work seamlessly. It also helps you with things like load balancing. On the back end, not so much, but if you have a very heavy workload coming in, you can easily scale up those services, and you can easily just route traffic through to each individual service. And that's the reason why we went with this pattern. The other benefits to that is, let's say in the future we have a huge application, something we have identified there's a huge need for a new feature, but we know that C# isn't very good at doing that. So we hire a bunch of Python developers or maybe Ruby on Rails, anything really, and all we really need to do is just plug that in. Now, obviously it's not that simple because there is one final piece of the puzzle, which is this little rabbit in the bottom left-hand side here. And the responsibilities of that is to really allow these services to seamlessly integrate with one another. And that is an advanced message queue protocol service. It's called RabbitMQ, and it's effectively allowing services to communicate with one another in a fairly uniform way. In our case, we're using JSON. And what this basically means is if you have a Python service that needs some sort of information from service 2 that's built in .NET Core, what you can do is you can pass a message through to that. The service 2 will have what's called a consumer. It will pick up that message and it will give, and it will simply either respond to service 4 or potentially as a workload that doesn't require a response, so it allows you to also fire and forget messages. And this works very, very well because the payloads inside of those message queues, those messages, are basically tiny, and really it's having the opportunity to fire and forget these messages really gives you the opportunity to worry less about controlling what happens to data through services that need to be coupled, and let you get on with the more important things like business logic and database modeling and things like that. Finally, which probably gathers from the way I've explained all this and what I mentioned earlier, we're also using agile methodologies, Scrum-based, where we can do weekly sprints, they're called. Agile is quite a big topic to discuss, so I'm going to be very brief about that. For those of you not familiar, it's very popular right now. It really allows development teams to set a series of goals, and by the end of that week, hopefully have those tasks completed and moving on to the next needed task within the backlog of tasks you may have for your application. Of course, I mentioned earlier that we've got the model and controller being resolved being sorted by the MVC.NET Core Web Framework. So that kind of leaves the view side of things, which in a lot of people's minds they call it the front end. Front end development is becoming its own large beast, and I think everybody would agree with me nowadays that really to build a great front end, you need good front end developers. And so we need to ask ourselves, what do we need? And the answer was a framework to provide an interface that users can display and interact with, something lightweight and something simple. So what I want to do is just go through some of the choices we had. I won't go into too much detail, mainly because we don't have time for that, and I think I'm already running out of time. So we'll start with Vue, which in my experience, Vue is a great web framework, a great web application framework and a great JavaScript framework, library, whatever you want to call it. But in my eyes, it's still quite immature, it's still quite fresh on a lot of people's minds. And there are two large behemoths that really shadow Vue.js at the moment. And the next one of that is Angular.js, which I'm sure if any of you are developers or engineers, you'll be very familiar with Angular. I really enjoyed working with Angular in the past, and the way it uses TypeScript to make building web applications type-friendly in JavaScript, essentially, as a superset. But I do feel like it's almost too bloated for the means that we need it for. So as a result, we decided to go against that and mark it as a bit too bloated. So that leaves the last behemoth, which I'm sure, hopefully, again, if you're engineers, you'll be familiar with, which is React. React is a Facebook-based JavaScript library, and the little symbol below that is Redux, which helps us with state management and store management, which, again, is a whole other topic, which I'm sure we could talk about after. So we decided to go with React, and the reason why that is just because it's a much lighter framework, a much lighter library. Gives you a lot of flexibility in what you want to do. You can make mistakes much easier. But the payoff in how quickly you can get something up and running is just much better than what I believe Angular can give. Vue is very similar. Vue.js is very similar, but React for me is much more comfortable, and as an organisation, we decided it was a better option of the three. So moving on from that, we've then got some more important, other important topics, such as the operational side of things. It's becoming such an important topic nowadays that DevOps is growing as its own breed of topic. Everybody's talking about DevOps nowadays, and so I'd like to start with just continuous integration. I'm sure most of you, again, if you're engineers, are very familiar with this. It's a much more modern approach. The previous system, the legacy system, actually didn't have any continuous integration or continuous deployment in place, which really added to that slow, less automated process that we really wanted with this Cloud Computing 2.0. So as you'll again, if you are familiar with continuous integration, there are two giants and one upcoming giant in my opinion, and that's Travis CI, Concourse, and Jenkins. Now, the question we needed answering this time of what we needed, and at the end of the answer being, is an automated solution to help keep bugs out and save time using build pipelines. Now, all three of these will achieve that fairly well. They all effectively do the same thing underneath the hood. The reason why we actually went with Jenkins in the end is because the problems with Travis CI is it's entirely a SaaS at this point in time. You can get the enterprise solutions, but it's not worth the effort. It's quite an expensive thing to really get into. Concourse is a fairly new player to the CI/CD type environment, and it's a great option, but I feel like it's still quite immature. And to be perfectly honest, I've not got a lot of experience with it. So from the company side of things, we wanted things to be done quickly. We wanted them to be done efficiently and to use something that we're all familiar with. And many people nowadays seem to be very, very familiar with Jenkins. And the good thing about Jenkins is it allows you to integrate with things like Slack for your communication, GitHub for your automated builds or automated unit tests, and anything else really. It's got a lot of integrations. It can send you emails about builds, it can tell you what the problem is. It's a fantastic piece of software, and if you're not using it, or using a CI in general, I definitely implore you to at least look into it, because CI can save you a lot of headaches in the QA process. It can really pick up a lot of bugs before you really find out about them in real-world environments. Moving on to continuous deployment. So a lot of people tend to put both CI and CD in the same bucket, but really continuous deployment is all about what you put at the end of that process to help support the product you're building. So the answer we needed for this is an orchestrator that can scale indefinitely, monitor it from one location, has a proven track record. For an orchestrator, there are two mammoth choices at the moment. I don't really know of any that even compete on the same level as them, and that's Docker and Kubernetes, who they're just solid options. The orchestrator is essentially something that can help us to deploy builds, fairly seamlessly update and upgrade systems almost effortlessly. You deploy a Kubernetes orchestrator, you configure it the right way, you can have that integrate so well and seamlessly with your build pipeline that by the end of it, when you push a button, you can have a system in production in several different locations all at once. This is the output essentially. This is the architecture that we decided to go with the front end, back end, and the back end cloud services. So those of you who are front end engineers will probably be familiar with the front. Those of you that are back end engineers will be familiar with the back mostly. The kind of shortcuts we're taking here are, rather than worrying about databases being deployed locally and also worrying about storage on local container volumes, we've decided to opt in for cloud-based solutions because they just allow you to make services and build services more atomic and ethereal, and just you don't have to worry so much about them. Thank you. I guess that's it from me.